maybe 10 years back. Okay, 2015, I did that this presentation for my defense, PhD defense. Okay. So some portion, if you feel that it is not relevant to you, you can tell me, I will skip. Actually, in my PhD work, I worked in the utilization of integrated steel band waste, mainly iron ore line as well as the bottomless, because fires at that time also some work was done, as well as some utilization was there, but bottomless utilization was almost nil at that time. So then some area like utilization as a bed materials of bottomless for making the different bricks like geopolymer, construction bricks, insulation bricks, and fourth part was like for metal extraction from the bottomless. So metal extraction part in smelting reduction lecture I will discuss. Mainly 3-4 parts I will discuss. Some slides I have taken from different sources. It may be some orientation will be different, some logos will be there. Okay, please ignore that. Before starting, just I can introduce you regarding our NIT Durgapur. It was established in 1960 as Regional Engineering College, RE College, and till 2003-04 it was affiliated to University of Harvard. 2003-04 it transformed to NIT Durgapur, a centrally funded technical institution with deemed university. In 2027, the institute, an institute of national importance, because NIT Act was declared. 2009, we received the NIT statute for NIT 2009, and we are autonomous institute. Ranking, I think, up to 2022, I have just here. Now it is 7. Okay. We have engineering department. We have engineering department, biotechnology department, like chemistry. We have integrated chemistry, MSc in chemistry, physics, and EES, art and environment science. We have management department and also humanities. We offer undergraduate program. We have added here like BTech, 12 degree integrated MSc undergraduate program, postgraduate program, MTech, MSc, MD, MSW, and PhD program, 2 types regular and professional. Like from ISP, DSP, like one student is sitting there. He is doing PhD under my supervision. Logachandra also is doing PhD. And postdoctoral research. We offered BTech in biotech, chemical, civil, computer science, electronics, electrical, mechanical, metallurgy, and MTech in biotechnology. This is the undergraduate program. BTech and MTech in biotechnology, chemical, as well as the chemistry, and we have introduced maths and computing. Okay, from last year. There are different MTech programs. Okay, in MME, we have different fields of research area like environmental, physical, advanced materials, modeling, mechanical, and we are working in process or extractive metallurgy area. These are the faculty profiles. As Nausad sir told, like like regarding CSIRO connection with NIT Durgapur, what happened? Actually, at that time, CSIRO is an organization like our CSIR. The government of Australia, they they given some fund and to make a relationship between Australia and India towards the critical minerals as well as the green steel research. So at that time they were searching for some institute who are capable to do this work. Then we have given some our proposal to them. Then a lot of organizations they have participated like IMT, Tata Steel, IIT Kharagpur. Luckily, we got first institute. We have been selected as the first institute to conduct a green steel research center, green steel research under India Australia Mineral Scholar Network program. So before that, a lot of visit. They visited here, our department, CSIRO delegates. They visited our lab, infrastructure, etc. Different times. And then the India Australia Mineral Scholar Network program announced officially by the joint Prime Minister bilateral agreement. And first, as a first initiative, we sent our research for Abbas for 1 year there with full internship. And now again, we have selected one postdoc. We are recruiting one postdoc under another project from CSIR Australia. Just 8 was the interview. We have selected one candidate who will also work here as well as the Australia. So regarding waste utilization generated from the steel plant as well as the thermal power generation, I have skipped a lot of things like to emphasize these two areas because our course theme was on the decarbonization of steel industry as well as the power generation. Therefore, I have taken two plants. As I discussed, this is a part of my PhD defense PPT. Therefore, it will be this like chapter 1. Their slide will be chapter 1.1. Okay. So, the steel is the backbone, and India was actually second largest. Okay, second largest. Nearly about 150 million tons steel is produced, but problem is it generates a solid waste like slag, it may be from blast furnace, but fly ash, bottom ash from the power plant. If we consider the integrated steel plant, which having the facility of thermal power generation also. And ore fines and slime from beneficiation plant, coke fines from coke oven plant, a lot of other waste is also generating. Like you can see, this is just another one in 2015. Therefore, as per their data, from integrated steel plant, if you see, iron ore tailings and slag means lower side, which cannot be directly charged into blast furnace. If you consider it, it is the 43%, and CCR, including all, means fly ash, bottom ash, boiler slag, it will be near about 41%. So these are the some generation statistics I am going faster. So at that time, I was instructed that you use some waste material which is not utilized majorly. Then if you see at that time, iron ore fines is from the iron ore process, blast furnace slag. But if you see the waste utilized, iron ore fines is somehow it is utilizing like for sheeter making, some pellets making. Blast furnace slag also So cement plant. Okay. Steel making slag also some area for utilization. But we identified two major waste materials which were utilized. As a bulk utilization was not there. Little utilization was there. So we identified as the iron ore slag at the bottom because fires at that time some fires were used for treatment. So if you see the impact of this integrated steel plant, so the economically you are losing the value of the metal that you are using. But it could be adjusted. You are losing some amount of value, and if you increase the production cost, the product cost, it will be managed somehow. It is not a solution, but somehow it can be managed. Disposal, it is a problem, but if you have a lot of land, you can manage. But if you see, in case of environmental pollution, you cannot ignore because nowadays the strict regulation due to the environmental policy. Then this point you can consider only. You have to consider all, but if you only consider this one, there will be no way.
The solid waste disposal is also a very broad issue.
I am telling you, you cannot ignore it.
No.
But if you can manage it, the red one is like could be adjusted. Could be adjusted as an alternative, but you cannot adjust this one. Okay. So then the question will be disposal is like plant killing is one way of disposal. But recycling is another way of utilization where you can get some money or you can utilize property to avoid the environmental pollution. Recycling in this way like conversion into value-added products. This is more attractive because the bulk utilization can be possible. Bulk utilization means if you are producing some bricks, it means total raw materials will be utilized. But when we are talking about the second, hello?
Yes.
But if you see recovery of the valuable metal, what will happen? You can get or recover the valuables from the waste. But there will be another problem of this recovery and this value. The generation of the secondary waste. What is the secondary waste? Primary was like highest primary. So when you want to extract the valuables from the tires, suppose 5% valuables are 95% waste, then after processing of this waste, you will generate another waste, secondary. This is one problem, the secondary waste generation. Okay. And sometimes what is happening, like suppose sir was telling the recovery of RE or critical minerals, the quantity is very low. Therefore, processing cost sometimes it increases. Okay. Like if you want to extract by biometal level, it means you have to heat it up to the melting temperature. Okay. So slag generation temperature is very high, like 1500 or more. Then you have to heat all the things up to 1500 degrees centigrade temperature to extract suppose 1 gram, 2 grams metal. Then the production cost will be here. These are the problems. Then I will speak that one because it is a major things I am telling like iron ore contains alumina. Therefore, this iron ore line you cannot directly charge into the or making the pellets. Okay, because this line
generally still now if you see major beneficial and processes wet chemistry. Dry beneficial process is limited. Still now it is not commercial use, it is used but very lower amount beneficial and process is used inside dry beneficial. Then this is another issue. And water generated after washing what happens? It contains the smell. Okay. Then it goes to the slime. Then it creates another problem. And if you see the finally slime contains iron. If you want to dispose this like for in the low land area or surface materials, then you are using the metal, which is near about 80 million tons per year. So therefore, another literature like bottomless, like 70 to 80% of coal mine in India is used by the thermal power, and the bottomless is like in next slide I can show you. This is you can see the thermal. This is up to the like 2012 data. But you can see that there is quite difference. Thermal power plant is dominating for the power generation. Okay. And it was predicted like 31-32, a huge amount of electricity required. Okay. And requirement in different areas like all the requirement for electricity is reduced. The predicted was like 30-31 at that time. And you can see 200 million tons of CCR, including fires, bottomless, and boiler slag. It will generate like near about 200 million tons by what you are finding for the reduction at that time. You know the bottomless for this the bottomless for industry like flyers, yeah, in collected and bottomless on the bottom. If we clearly if you can see the bottomless is mainly formed by the PCC boiler or a paper from the FPC boiler. PCC means pulverized coal injection. Just major power plant they are using the PCC. But if you see the smaller scale power plant, they are using FPC also to regulate combustion system. The basic difference is like that heat generation, production of the heat. If you see high combustion temperature like 350, they are lower combustion. And this is the beauty why the different types of bottomless having different types of bottomless. If you categorize the bottomless, what will happen? You can see the PCC type of bottomless having different property of bottomless generated from the ABC bottomless. Because here I mentioned like due to short residence time, what happens? The volatiles are entered in the molten ash. Therefore, you get the senosphere having the hollow senosphere. Sometimes senosphere of solidification of field. Senosphere, what is this? Senosphere is actually the melted slag. Okay, it forms a molten slag at high temperature. Ash is combined to form a molten slag, and it is viscous slag because it contains only the silica alumina, majorly silica alumina. Okay, until analysis add some another carbonate materials, it will the melting point will be higher. So this is the viscous slag generated, and as it is the fine coal is injected, what happens during the burning? Instantly it will burn, and what happens? The slag will generate. Slag is viscous in nature. Then what happens? Inside when these bubbles will form, what will happen? It is viscous in nature. It will not easily come out from the system. It is viscous in nature. Therefore, generally the hollow cells are produced in fires. Okay. But this is similar for both types. But if you see bottomless, why that type of bottomless, different bottomless produce, bottomless will produce, but it will not produce a slagless product. Means it will not produce some viscous melting material. Just for example, like you can see some in tea shop, you can see some like कोयले का जो ये फर्नेस है, कोयले का जो चूल्हा है, ये शॉप में देखो चूल्हा है, तो if you see the ash generation, it will be like the ash generated from the FBC type of it. Okay, it means it will be the solid in nature. It will not form the slag, and as it forms the slag and gas is entrapped, therefore the bottomless produced in the PCC boiler, it will be porous in nature. This is the difference between the PCC bottomless and the FBC bottomless. Okay. I will show you the difference in different properties. We have different things like generally hot element. You can see at XRD analysis if you see iron slime is the major one in case of iron gauge is the major, hematite is the major, followed by the silica in case of iron slime. And when we talk about their particle size, if you see like there sleep, playing nature is finally different very proportion you can see here. In case of bottomless, if you see property wise, particle size is very less. Why I am saying this one? You can correlate this one. Almost remaining property is similar to the sand. Okay. Particle size is 0.0121, 0.075. Okay. Specific gravity almost similar. CC coefficient of carbon, who are the simple people they can understand much better. Almost similar. Compaction property, you see high compaction energy at static space. Internal friction is more for bottomless than the sand due to the interlocking. Because it is popcorn-like structure, I already discussed. So when you go for the friction test, interlocking property means one materials will be interlocked to another. Therefore, it will give you the more bottomless than sand due to the interlocking property, internal friction which are high. But if you see the coefficient of permeability, it decreases more after loading into the materials. Actually, initially it will show the high, but when you give the pressure, but as it is popcorn-like structure, after a certain load it will break. Yeah. Then what will happen? Coefficient of permeability will decrease. It will decrease. Yeah. And crushing coefficient is more at lower load, but more at higher load due to the loss of strength. And weight filter criteria fulfills partially in case of bottom. But sand is used as a weight filter materials. Who are working in this area, you know the weight filter materials. I discuss the weight filter materials. What is the weight filter material? Why is it? What is construction of the ash type?
The question in case of ash is near to zero, the cohesion value, the C value of ash is near to zero. So the internal friction is more, but the cohesion is zero. So isn't that contradictory?
At initial stage it is hard. Okay. But when you go for higher load, and if you do the experiment at higher load condition, what will happen? Sand will not degrade so much, but bottomless will degrade more due to the porous type structure. Therefore, after a certain load, it will behave like the sand, but after that, it will not behave like the sand. This is the point. Then we have this here at that time we have done the literature survey like in which area people survive, like in different beneficiation process for utilizing the iron ore slime. Research paper was almost 90%. Okay, these people are working how to beneficiate the iron ore slime and to utilize it. Okay, and some area, some people they have near about 10%. They are engaged for 1% into the ceramic products, okay, like by hiring method, by clearing method to make the construction bricks, ceramic tiles, lightweight ceramics, and then another thing which we discussed yesterday, that guys, like the geopolymer bricks. Okay, it is called the autoclave bricks. And we have also done the integral study, what is the utilization of the product, how research is going on. 10 years back, at that time we observed that some area like flotation, okay, for construction product, for separation of carbon, separation of dyes, I would say, ink dye. The construction product like cement and sand substitute, old quantity index, etc. for absorbent, fire resistant particles, etc. In this way,
Sir, what is center in alumina plated second?
which one?
Second. What is center and acid leaching? What are the
Cement and
center and acid leaching? In alumina.
oh, this is the process. Right side you can see. This is the area, separation area. What is going on in the area like flotation process? They have separated heat, alumina. They have separated carbon by flotation method. Okay, alumina by sintering acid leaching. It is actually I told na the utilization of bias is for extracting the aluminium. In China, they are. The method is, it is called the sinter followed by acid leaching. So soda lime sinter process. And carbon, if you see the result, 53% carbon can be recovered from the bottom.
After
In
you
this way,
that carbon will contain the calorific value.
yes, people are doing like after separation of this carbon again revert back to the coal. It is mixed with the coal. We can inject. Okay. And we have got some literature like people they have also tried geopolymer and bricks making. Okay. Then if you see at that time, scenario you can see what kind of simulation are geo. I have it's at that time I talked to the detailed guys also. Why this automatic simulation is less? If you see automatic generation, can you tell anybody how much automatic is there?
20%.
It varies
20%.
10 to 25%. On an average, it is called like 10 to 25%. Therefore, they told me actually we dumped it in a single glass form. Because quantity is less, therefore we do not segregate. So in details, people are no, offer. So now I think you have separate area. We don't dump in asphalt, we have dry bottles. So we goes in the silo, those speckles take away. Different land filling and somewhere else. Then we found like water mass has not been used as a bed feeder because the water mass property is not suitable, it is not suitable to achieve the property of asphalt because it requires the bed feeder material property as well. Water mass utilization has not been explored in building bricks, maybe the geopolymer. And water mass and swine, co-resistance is co-utilization was not in the literature. Swine and water mass had not been exploited for the production of K-virus, which extraction. Why I am taking about the co-utilization? I will show you the particle size. If you see the particle spectra, you can see the iron ore line likes is clay in nature, and bottom mass is poor sand in nature. I will show you. So then when the slide will come, I will describe. So we have taken the raw materials iron ore line, bottom mass from Ultramati PCC and PCC, and collected ATPC filter. The different tests we have done, sieve analysis, hydrometer density, bone penetrometer, compaction test, CR test, permeability test, CDR test, surface area, same. Okay. We have done different experiments as per the ISM standard. Size, same, text, bulk density, specific gravity, specific surface area, approximate, chemical analysis, phase analysis, pH. Then this is the result. If you see these three metals, iron line, the BC watermelon, BCC water. You can see the distribution, right? It is, you can see the compound structure, but it is very finite. But here you can see agglomerated one, porcelain. You can see from the image, you can see this is a solid particles. You can see that particles are the solid in that, but here you can see the hollow particles, compound structure and porous structure. Then when you see almost the similar type of composition in this house, this is XRD analysis. So this is the iron ore line dominating the quartz hematite pages and sorry, the iron ore line on hematite pages, quartz aluminum pages are here. The PC bottomers and PCC bottomers having the quartz is the middle one. Okay. Then we have done geotechnical properties because you know geotechnical properties is required before assessing the properties. Because if you want to use the sub-base methods, road construction methods, the geotechnical properties is important. Then we have done geotechnical properties like rocker test, shear test, caliber test, liquidity, permeability, etc. You can see compaction test. This is for the PCC. It is near to convertible, but it gives to the ATPC. This ion. Okay. And this one the PCC. Dry density is 1.64 gram per cc. Dry density is 1.2. From here also you will see, you can observe like this is the denser material. Okay, this is the denser material. Solid material. And also the dry density is high. Yeah. Shear test. This is very interesting. You can see at the lower load, both will show you the almost similar type of lower load. It means PCC and NPC both documents will show you almost similar wicket at lower load. But what happens at the higher load? When you go for the 1.5 kg load, what will happen? You can see drastically decrease. Because if the performance factor, when you use the load, it will come to break. Therefore, the shear stress will decrease drastically. And frictional angle almost it is similar, but APC is higher. Compressibility. You can see the ABC less compressibility. But you can see if you apply the load in case of PCC, it will compress more. Compressibility is high. This is also the CDR test bearing resistance. Then you can see this one. Iron line lies in the area of clay or steel. Okay. But if you see the APC bottomers, like the closed structure in this one. And in the PCC bottomers, it is near about the finer sandstone. Then you have it, and it is like a sand, both are sand area. Obviously, we should put in the intermediate part. Then, actually, for bed intermediates, what is the concept? have not tested in real field. Therefore, we have to test in some properties so that we can predict, yes, it will be applicable. Then, this is the different parameters which is required to measure the temperature maintenance. Then we have determined from the literature also, we have taken out the data from the literature, and we have also determined the same thing. Okay, and this is the criteria. If it fulfills, then you can suggest this material can be used as a material. What are the criteria? Criteria number 1. Minimum D15 of the filter material should be greater than or equals to 5 times of D15 of the base one. If you want to use the well-treated materials like sand, then it should be greater than or equal to the base pulp. Base pulp is any base pulp like fire river making the dams. Okay. Then these are the criteria we have to fulfill. Then you can see. We have observed that criteria number 1, 2, 3, 4. These 4 criteria should be fulfilled. Otherwise, you cannot do it. You can see river sand. All criteria. Okay. ABC bottom it is fulfilling all that. But ECC bottleneck is not fulfilling. Therefore, before that, nobody used bottleneck as a filter, weight filter. Because at that time the PCC bottleneck was available. But, sorry, interestingly, ABC bottleneck can fulfill all the criteria. Then, filter design suitability we have observed for ponders. We want to report it in detail. If you can think the ponders, what is the suitability of ponders with APC and ponders with PCC. Then you have also observed that yes, APC bottleneck, if you can design, if you want to design a filter material which is suitable for ponders, the PC bottleneck presents to all aspects. But in case of PCC bottleneck, not that. Okay. Then this is the conclusion, like potentially you can use the APC bottlenecks at a given. We tried to implement it because the document PhD at that time okay, chalo. But we did not try in real use as like one. Then the
Presently,
second,
we are doing the dye strengthening work with the use of NPC.
APC or PC.
Finer ash.
Final, I think you are mixing bottom as well as unbinding from ponders.
From ponders, the
Therefore, it
finer
is
particles.
therefore it is fulfilled. Right. Then another area is like utilization of bottom mass or geopolymer. So geopolymerization is short. It is actually alkali activated aluminum. This is actually EUC, all geopolymer having SiO(Al). It may be other components will be there, but basic components should be SiO(Al). Okay. This network should form. So what is this? That the dissolution of aluminum and silicon oxide from aluminum silicate into strong alkaline or liquid presence. Then it will form the silicon. I'm not going into details. So what is that we ideally like we have taken raw materials from a piece to CC. And each we have taken activators like sodium hydroxide. I have tried to get different curing temperature and temperature. These factors are responsible for making the bricks, like what you are using, like fire bricks, geopolymers. Some bricks you can see like less strength, some bricks like higher strength. It depends upon the how, which type of alkali you have added, number one, and activators which you have added during time, during temperature, etc. Then this is the project like bottomless screening, because they are grinding is required, because bottomless has higher force and nature, so they have to grind, and why grinding is required to get the more surface, because geopolymerization reaction requires higher surface area. So then we mix trace, pure and distilled, different properties. So bottomless like 0.75 mm size, both BC and PCC, sodium silicate in this concentration are added, sodium hydroxide. Okay, these are the tablets we have to prepare, tested in. These are the results. Lot of results are there. Ultimately, what I can show you, highlight it like increasing the curing temperature, increasing the curing temperature, almost the strain has been increased. But somehow after that it is gradually increasing. Therefore, because temperature should be optimum, so 65 degree temperature was the optimum in our cases, because it will vary case to case, because the chemical composition of the water may be different, concentration of the alkali may be different, activators may be different. Therefore, in our case, we have simply 65 because if you see, if you pure for up to 72 days, it means it is days, curing time, sorry, it is curing time in hours, 72 hours. Okay, and you can see here you are getting up to the 40 hours, you are getting similar time also. Okay, and this is the this one is APC curing temperature 50, and when you go for the PCC bottom, okay, you can see high amount of steam. Okay, and the molar concentration is alkali concentration, increasing the alkali concentration, you can get the most. And PCC having higher response for making the geopolymer as compared to the NPC. This is because APC is solid type of particles and PCC is the follower one. So effectively alkali can penetrate and it can form the oligomers. That is the oligomers. This oligomers actually makes the network of geopolymerization reaction. So this is water absorption, means how much water absorption is required. Why it is required? Because if you want to make a construction dig, then how much will increase? Then what will happen? How much water can absorb? Because if your water absorption is very high, it will create the problem. So you cannot prepare the ground, means ground floor by this direction. It will absorb more moisture. Whatever you can see, some spots are there, like water, when it will capillary action water will come. If the water absorption capacity is very high, it will absorb more amount of moisture. Therefore, generally people suggest you can prepare your building first floor and onwards, not in the ground floor. Okay.
There's a liner materials can also be made. Liner materials.
Liner materials can also. Then this is the apparent density. This is not also our. This is the edge in this different phase how bound and why strength is developed. So this is the effect of curing time. You see curing time gradually increases in the silica. This is the free silica. How you can predict that geopolymerization is increasing? When this silica peak will gradually decrease. Decrease what? This silica peak will go to this here the peak is very shorter. Here you can see peak is very high. It means this peak, the silica, it is major amount of silica, it will dissolve and it will form the geoparticles. Okay, this is the indicator. This is the API analysis to see the volumes. This is the same image of after geopolymerization. This white is the actually geopolymer formation. Okay. When you see under microscope, you can see this type of white edges are there. If you do that analysis, depth analysis, then you can see that alumina silica network is formed. Alumina silica network. Then this is actually the mechanism like how this geopolymer is formed. Then this is the conclusion. The rate of geopolymerization is quicker initially in case of APC bottomers, then PC slow. Why is it quicker? Because APC bottomers do not have this silica is generally present as the free silica. But in case of PCC bottomers, as the combustion temperature is high, alumina or silica it presents as aluminum not as a silica in the pit. But in case of LPC, as melting temperature is temperature is less than the aluminum temperature, the aluminum formation of the silica is present as the free silica aluminum. Then it can easily react. But in case of PCC particle, it requires some time for dissolution. Therefore, initially, if you see the LPC bottomers will give you the more strength. It's geopolymerized particle is faster. But ultimately, if you see, we have shown in PCC bottom mass, which shows the more geopolymer. Because if this is the particles, like suppose this is the solid one, the PCC bottom mass, suppose silica is there. This silica. The surface area, silica presence at the surface, it will easily react to form the geopolymer. But as it is the solid in nature, what will happen? Kinetics of the reaction, it will be slower. Right? It will gradually penetrate, then only next stage of the geopolymerization is possible. Okay? But in case of PCC, as it is the very already porous in nature, suppose it is porous in nature, geopolymerization can start there. It can start from the middle, center, side, in every area. Therefore, ultimately, initial stage, if you see, initial stage, if you see, whatever geopolymerization is faster, but ultimately, in case of PCC, overall geopolymerization is done. Okay. Then we tested it in as a insulation. The driving force for insulation is what like when we characterize the iron ore slab and bottom mass, we observe like iron ore slab is it should have some binding strength and bonding property with it. Claim we generally use for binding purpose. And bottom mass is pore material. Then what will happen? Pore material generally interparticle space is high. Smaller particle space, interparticle space. Yes. But when the materials in pores are in nature, interparticle space will be big. Because we felt in case of geopolymerization, we did not get so much strain of that due to the pores are in nature of bottom mass. It requires fineness, grinding, which is energy consuming to make the geopolymer. Then, but like we can make the construction things. Okay. Then we have tried iron ore slime addition as a binder. Okay, I will contrast labor. And both are materials that have 4 permeant. 4 permeant interparticle space will be there. It means if we add some binder, which will accumulate the coarser particles, then it will give the solution. That was our idea at that time. Then we prepared like fineness of the bottom is only 1 mm. You can see in case of geopolymer 0.001 slime content will vary from up to 50%. And different temperature required and we try for APC and PCC products. Both products. This is the screening of your content, mixing, testing, firing, and this is the different heating cycles. We have taken APC and PCC and different composition, hydrogen composition. These are the peaks, fire at different temperature, and the result. You can see the cold crushing strength. Okay, it is for LPC and it is for fuse. Fuse different in the strength. In case of LPC product, it gives a very high strength. And you can see it's specific standard, it is IS 204. It requires air. It means it does not fulfill the insulation property in case of LPC product. Okay. But here you can see, yes, if you adjust some properties, you can get in this range very specific. Means bricks which will produce, it will give the insulation property as per the IS 204. From this work, we identify this is the apparent porosity. You can see apparent porosity. Apparent porosity will be as per the IS 2042. Although the strain as well as the porosity both are right. So here you can see porosity is not matching. Some batches it is matching, but almost it is not matching. Like 1, 2, 3, this are matching. But here you can see almost all bricks satisfy the criteria of the apparent porosity, which is required as per the standard, high standard. This is the water absorption. This is also, you can see, this is also matching here. Bulk density is actually not for the it is not required for high standard. So PLC is required, carbon linear change. Then we compare the APC bottleneck bricks and standard bricks. We have identified the bricks specimen 1000, 1200, 1255. Okay, and there you can see iron ore strength on 0 to 60% means up to 50%, 10, 20, 30, 40, 50%. In case of LPC and in case of metal for the PCC. Okay. We have prepared the standard bricks and compared. Because always what happens in case of laboratory test, sometimes you will get some good result. But when you want to prepare a larger size bricks, then sometimes it will not satisfy the target. Therefore, we prepare large size. Thermal conductivity property is also required. You can see the PCC water match. There is thermal conductivity. It is measured at different temperatures, 200, 400, and as per the IS standard. This is the extractive phase of this is the mechanism actually. Like as it is a popcorn-like structure, when it produces, it gives some open spaces inside the bricks, which actually increases the thermal insulation property. From the fire phase, conclude like high temperature and iron slag content will increase the strain. But adversely, with both parameters will decrease the thermal insulation property. And finally, the bricks produced by ECC bottom technologies fulfill the requirement of insulation as per IS 204. Why not LPC? Because LPC is solvent. I am discussing